Okay. How are we?
Fine.
Yeah, very, very fine. Now we are back into another topic. Remember that we dealt with topic 1, and that was the first meeting, and we looked at number bases as a system of counting in groups. Then today right away we are introducing in another topic 2, and I request that the instruments we mentioned in topic 1, that's a calculator, mathematical set, long ruler of about 30 centimeters. Then as a student of math, you should have rough papers or a rough book. That's for checking, and you should have a pencil to roughly check the answer very fast, because speed and accuracy are part of a mathematician. Now we say this math is a language, and indeed we want to understand that language. Now let us put the topic that we said we would put. That's topic 2. Remember, topic 1 was number bases. Then topic 2 is number systems and integers. Number systems and integers. That means there are 2 key subtopics where we shall visit numbers, number systems. That means under number systems we shall see types of numbers. That is where you find your numbers to count. And the other one will be the integers. Yeah, integers. Now it will not be very, very long. It will be slightly short. And right away, let us look at number systems. And we shall visit what's a number. So, what is a number? Then we visit types of numbers. Then we shall also visit factors and primal factors. Is there a difference between the two? Then we shall visit multiples. We visit highest common factor or greatest. Highest or greatest common factor. Then the lowest common multiple. The multiple is the lowest, the factor is highest. So now we shall also visit some word problems in word problems in HCF and LC. Prime factorization and roots. Prime factorization and roots. And roots. So, then upon seeing that, some simple operations like adding numbers, I think this is well acquainted, simple operations. numbers, then place values and reading in words. Place values and reading in words, reading in words, in words. See? That one will be the end of the number systems. Then we shall speak of integers, or what we call directed numbers. Directed, they have a direction. So now let us start right away. What's a number? See? What's a number? If that question was, since you always talk about number one, what's really a number? So yes, Chirabo, she wants to say a number is what? See.
A number is like a digit that is used to represent the amount of something.
See, that's very accurate. A number is a digit. You are simply saying another word for number is a digit. Yeah. But in the other sense, we can as well say, you see, when counting was first started, the Romans counted using what we call Roman numerals. So that means the counting was done first using what? Either Roman numerals or Hindu-Arabic numerals. Now, Roman numerals were abbreviated. These I think you saw them you met them in what? In our lower primary. Then the Hindu-Arabic numerals were the ones that were called 1, 2, etc. So, simply that means a number can either be a Roman numeral or a Hindu-Arabic numeral. Simply a number is a symbol of a numeral. So, a number is a symbol of numeral. Either it will be in digit form, as she said, or in Roman numeral form. So, you see, I think you see how we have come far from the ancient mathematicians. You really, if you saw how they could handle their mathematics, you'd really appreciate how that their heads were very good. That's where these calculators were developed, as we shall see that these operate on programs. See? Yeah, on programs. Even you can, if you could only realize the codes and the program installed here, you can calculate those numbers. See? Yeah. Like we shall see ahead there, that whenever they are dividing a number by 2, see, for them they could code it as say, if they divide by 2, for them it is simpler to multiply by 4. Like if you say the 50 over 2, it is giving you 25, but when you multiply, to divide by 2 is to multiply by 5. That means the multiplication of 50 by 5 and you cancel 0, you get the same. It's just coding. See? That when we say 20 divided by 5 is simply times 4. I mean times 2. 2 and 5 are coded in systems. That means if for you also code your head for every value you're dividing with, you can realize that you can have those answers without a calculator. So now that is by the way. Let us we said a number is a symbol of a numeral, so which can either be in Hindu Arabic format or in Romani numeral format. Yeah, that's it. Now, yeah, as you see, as we move through these numbers here, we shall be seeing the language. See? Now, types of numbers. Types of numbers. Yeah, I hope you have some. Could you begin contributing some and their meanings? See, at least 3, not so? Yeah. Start with who? I hope you don't mention your friend so that he gets exhausted. You are saying counting numbers. Yeah? What are they?
These are numbers that are used when counting.
When used when? Counting. See? They run from?
1
to? 1 to infinity. What does that word infinity mean? Yeah. Infinity is a point where you can't reach. Even where you are there, it's my infinity. So, because even if I stretch the hand, you see, but they continue up to where you can't count. But of course, these days you can count. Yeah, as we shall see in reading in words, when we reach 1 million, 1 billion, then where do we reach? Past a trillion. See? You see, that's, I don't know whether that money exists. So they're also called natural numbers. I don't know who made them, but we know the mathematicians called them as natural. Next, you have 3. Even numbers. Even numbers are numbers which do what? Numbers divisible by 2. What are they? 0, 2, 4, 6, etc. So you don't want to mention 0? Because in the discovery of numbers, 0 was not first one. See, because we saw that in the counting in the base 10, the digits were first from 1 to, see, from 1 to what? To 9. See, now it's because that 0 came to replace missing spaces, then it was made. But it's inclusive, but not, though it divides it and leaves no remainder, but it has no qualification as even. So,
Odd numbers?
Odd numbers?
They are numbers that can't be divisible by 2.
Numbers that can't be?
Divisible by 2.
Are you very, very sure they can't? What do you mean to be not divisible by 2?
If you divide it by 2, fine, okay, like
They can be divided by
when you divide it by 2, you leave a remainder.
Okay, that means on division by 2 they leave a what? A remainder. What are they?
1,
2?
no, 3, 5,
3, 5,
7.
7. It is. That's exactly. Okay, now this other Kirabo's turn. What's the next?
whole number.
Whole, what are they?
These are numbers that
They run from
from 0 to infinity.
0 to infinity. Yeah. Next, you have 3.
Square numbers.
Square numbers, what are they?
They are numbers got after multiplying counting numbers to 10.
All numbers with the perfect square root. That you square each counting number, or you multiply it by itself. That would be 1, 4, 9, 16, etc. Next.
Triangular numbers.
Triangle, what are they?
They are numbers got after adding counting numbers. Okay.
That means they form patterns of a triangle on trying to draw their patterns. How do you generate them?
By adding.
By adding counting numbers. What is the first natural number? First triangular? 1. Next,
3.
the first is 1. The next is 1 plus 2. 3 next.
1 plus 2 plus 3, 6.
6. That means you have 1, 3, 6. Next, what would be?
10.
So, it is. Next, okay, you are done. Add me more numbers because they are still there. Yes?
Prime numbers.
Prime numbers. What are those numbers?
The numbers that have only one factor.
Have 2?
Factors, one and itself.
They have 2 prime numbers, or you call them primes. Primes. They are numbers with only 2 factors, or the numbers that can only divide themselves and 1. Is that very, very correct?
Yes, teacher.
The first one?
Yes.
3.
1.
One only. It has 1 itself only. 2,
3.
3,
5.
5, 6, 6.
7.
Okay.
11.
11,
13. 17.
17, it is. And yes? Rectangular. What are they? Rectangular numbers. What are they? What are rectangular? They form rectangular pattern. See? All natural numbers that are not prime are rectangular. See? Still to mention them now.
1.
If you draw their pattern, there will be a rectangle, but 1 is there, yes?
6.
4,
6.
6,
8.
9, 10, 12.
etc. As long as it's a natural number that is not a prime, you see, when you draw the pattern for 4, it will be a square, not so?
Yes.
Yes, a square is a rectangle with all sides equal. How can you say a square is a rectangle? That's mathematical. To say that is to be mathematical. So, a square is a rectangle. Yeah, when the sides have been made to be equal. So, next. Yes, exactly. They are still their numbers now. Yeah. Let me give you this a tube. What are they? Mention them. Chub.
1,
1,
8,
8,
11,
16. That means you are
18, teacher, 18.
18. What have you done?
3 times 3 times 3.
Are you sure you get 18?
No, 27.
See.
It's 27.
See that? Then 64, etc. etc. See. Now let's see there. What are they are still there? Hexagon. Now you are going to talk of decagon, you know. So composite. What are they? Are you very, very sure? But it had erased in the brain. What are they? Numbers that? They have beyond 2. That means they are from 3 and or more factors. That is?
We have 6.
6? Out of 4? 4. 6 also? 8? It is same. Yeah, that one goes to my head that at least we've spoken most of them. Most. So, factors and primal factors. Are we right here? You see this math, you see, you must have math in the hands. That means by the end of, you see, you must finish the course of senior 1 with math just being at your hands with the see. Now let us turn to factors and primal factors. See, factors and prime factors. What is to be a factor? What do you mean by a factor? And to now be prime if you're a factor. What's a factor? You are a factor, a big factors affecting I want Patience's answer. What is to be a factor? But could you give me an example of a factor of 6? Yes? 2 and 3. What is the relationship between 6 and 2 and 3? See? Yes.
2 and 3 can be multiplied to give us 6.
Then what is the relationship 6 and 2? 6 and 2 only. 6 can divide 2. To be a factor is to be exactly divisible by a number. See, that means 2 is a factor of 6. A factor is a number which is exactly divisible by another number. So, yeah. You see, that is very, very correct. Now you must know that the person who divides, as we shall see, is given a name called what? But if you say 6 divided by 2 you get, then what is 3? And what is 6 called? This is called the dividend, whereas this is called divisor or a factor. In case it divides accurately, it becomes a factor. See, then this is the answer is called quotient. Yeah, you must adopt the language of the math. See? The quotient, Q-U-O, quotient. Yeah, see? Yeah, now let us list some factors. That means you can test a factor by division, not so? Yes, you test by natural numbers. What are factors of 6? Start with all the natural numbers. 1 divides, 2 divides, 3 divides, only 6 divides, exactly. Factors of 24. 1 divides, 2 divides, 3, 4, 6, 8, 12, 24. See, that's correct. Now you see, these factors are so important, especially when they are designing codes. One time I sat to design, you remember those who were around when they had brought cards for airtime? I sat down to design airtime, see, but little did I know that that confusing numbers are built from factors, see? See. We shall see. Shall see. Okay, let us go to prime factors. What's a prime factor? A prime factor is just a prime number, a factor which is a prime number. If you say what are the prime factors of 6? 2 and 3. You see? Yeah, a prime factor is a factor which is a prime number. So, or a number that divides another number, but it must be first be a prime number. See? Okay, now that one throws us to what we are calling multiples. What's a multiple? Yes, Chelsea.
A multiple is a number that is put after multiplying a number by the factor.
See, that's very, very good to try. Do you mean that let us test 6? If we tested 6 times this, you are saying that that's 12, and that is 18. Then that is, have they ended?
No, teacher. I mean, like, you see, if you get 2 as a factor, when you get 1 and multiply it by 2, you get 2. But see, when you get 2 and multiply it by 2, you get 3 and multiply it by 2.
You get?
6. When you get your multiple, you have to list this.
The products.
Yes, you have to get the counting number and multiply it by.
I see, she said right? Because when you say the rounding number, then she put the hand on the what? See, that means to generate multiples, you use
Counting numbers.
so
So at least
it be, yes, factors, there will be limited. There will be a few. 0 won't cause any multiple. So that's why that 0 is only unique in all numbers. Not even even it is removed because it is nothing. See? So now you are saying the now multiples are what? See? Multiples of a number are?
The products got after multiplying the number by any counting.
We don't add to that. What are the multiples of 6? Mention them. 6, 12, 18. They are countless, not so? Are factors countless?
Yes. Yeah. No.
Factors of 12, are they countless?
No.
So
They are
that means multiples that are infinite. Now there is the language to be infinite is to be what?
endless.
So that's very accurate. Now multiples of 20, could you have some?
Yes.
That is
20,
20,
40,
40,
60,
60,
80.
80. Now, upon discussion of that, let us try to answer what we call her greatest common factor and how do we find it. See, now you are the ones guiding me there. GCF or HCF, another words. How do we get the HC? I would like a illustration.
I think they are independent, so we can
You think there are two? So, okay, let me pick a number. You come and give us the HCFs. So, but you have said there are two methods. Yes, each one demonstrates one method. So, yeah. Now, before we discuss those numbers, what would the greatest common factor mean to you? Yeah. Let me have Chirabo. What would that mean to you? Does it mean?
Okay, according to me, I
Mm.
think the greatest common factor means like if you list all the factors of a number, like if you list the factors of 6, then the greatest of it will be the GCF, the biggest number.
The biggest number? Then you have spoiled the issue. Let me hear from her, Cesar.
I think the highest common factor is any number that can be divisible by a number but has the greatest value.
You guys, you want to make me run mad. It has the greatest value. Oh, okay. That's okay. Now, that means the language is that it must be greatest. The question is saying find the maximum value. In other words, if we said that like in a family, if we are assuming I distribute money to Patience, if I give Patience 500 shillings and I give her 700, 500 and 800, and it happens that I have more money, what would be the maximum amount I can give them? See? That means I give you some, then I'm remaining with some. What is the highest? I've already, you see, I have a lot, but I've started by giving you some little. What is the maximum amount that I can give? You see? that language will be only answered by, see. You see. I hope you understand that now, assuming the patience is making for us things for Christmas, in case there is Christmas, that she's making 40 kilograms of what? Of rice, and 20 of what? Portion. Then which other food? The third food. And taking into account that the store is full, what is the maximum amount of each that she can make? You see, that same language is answered in. Yeah. Now you realize that a factor involves splitting a number. I don't know if somebody has heard that. You must understand, because when we say factors of 6, it is splitting down 6. See? Now that's why if a question is said, if now we said, she's making, if you are making, if maybe you are going to give me, say, 2,000 shillings, and you're also going to give me what? 3,000, and you still have more money. What is the greatest amount that each of you can give me? See? That splitting items is to breaking it into factors. You can only answer that to know how much each of you will give me, as long as you start by giving me maybe 2,000, assuming you had 1 million, you have maybe 2 million. Then when you start giving, you give me a little at a time, you give me a keep, she gives me a keep. Then if I want to know how much will you give me, maximally after total exhaustion of your pockets, I must use what? See? If whenever you are isolating things, breaking into looking at each's contribution, then that involves speaking about a factor. That's why when we turn it to LCM, see, we shall be speaking about law. Or the word lowest also means or least. Remember, a multiple is multiplication, does not split a number, but instead combines a number. See. Oh, what does that mean? Let us speak here. That now, if I said, see, if we said that if maybe you use 80 steps to move to the dormitory, then that one might be isolated. You are doing a job together. She washes 20 clothes, you wash 10 clothes. What is the minimum number of clothes that you can wash when you are together? There you are. You can wash when you are. That means as long as you combine things, because a multiple is a product of two things, combination of things is using lowest common mark. The two people read that a bell is rung like at your school here, they ring a bell at certain intervals, not so? Which time can those sounds be heard at the same time? if 3 bells, let's assume that you have 3 bells in the school. One is rang in the morning, one in the afternoon, one in the evening. Which time interval could they be rang together? Say together. So, but when you separate, you are factorizing, you are breaking into factors. Oh, that's right. Now you can know here that when we speak about greatest common factor, we are speaking about highest value, maximum value, splitting of items. See? I think we have really spoken of that language. This is involving what? Splitting. See? Because you are getting what? Factors. That means getting an answer for each of the objects independently is using greatest common what? So sometimes they can say find the maximum, you see, highest, see, yeah. Okay. I'm going to give you word problems here, and I will want to see which one will use a LCM and which one will use what? See? Yeah, that's very, very correct. Now, okay, let us turn here. You promised me not so, didn't you? So, find it there. Okay, to avoid the time wastage, let me also speak up. Since I've spoken about lowest common multiple, let me highlight its key terms here. Lowest common multiple. See? Lowest, find the minimum number. See? Minimum. Oh. And here it involves repetitions. Repeating events. Repetition of events is handled by lists. See that language there? Find the least amount of money that they can give the two. The two is the combining. That means here there is combining things, not splitting. See? Yeah, now the question is going to be find the LCM, then I'm going to give you the word problems here. You promised me 2 methods per LCM and per HCF. So, yeah, that's very correct. Let me 36, 60 and 84. Yeah, find the HCF and LCM of what? 30, 36, 60 and 84. See? Then when you finish that, I give you some word problems. Yeah, you're free. I'm going to grab this and yeah. Can we have you now? One is handling. Both you are handling. Okay, we have one person handle, then another one will come with the second method. Clear? See? Okay, come and handle HC. You are handling both? Both? Okay. Okay, come. You are handling. Are you going to handle method too? Okay. Handle it one.
the method I'm going to use is called the table method.
You remember you have Grace, you have two parts here you will use here and here. That means use it very well.
Okay.
But you can stand here, then you can face the other side. That fair?
Yeah. Finding the HCF of 36, 60, and 84. Since it is HCF according to this method, you have to use one factor that can divide all without leaving any remainder.
You have to use a prime factor or any factor. Which one is correct to stand?
A prime factor.
That's great.
2 divide, 36 divided by 2. 60 divided by 2. And then 84 divided by 2. We shall look at these numbers and then see which factor we can use to divide them without leaving any remainder. We can still use 2 or even 6. 3. You can use 2. So 18 divided by 2. 30 divided by 2. And then 42 divided by 2. Which factor? 3. By 3? By 3? Now when we reach at this step, we don't see any factor that can divide these without leaving any remainder. So we shall have to use these ones that we have used. So it will be 2 times 2 times 3 to give us 12. So the highest common factor is 12. Yeah? And then the LCM, we shall also use the table method. Should I use this? Yes. LCM of 36, 60, and 84. By 2, 18, by 2, 9, 15, 21. By 3, 5, 12. Then this is going to differ from this just slightly, because here we ended on the factors that won't leave any remainder, but here we are going to continue until we get 1 as our last digit. So we shall go by 3. 1 here it will remain 5 and 7. By 5, 1, 1, then 7. Then by 7, so we shall now multiply. 2 times 2 times 3 times 2 times 5 times 7 to give us I'm waiting for you. Oh my God. 2 times 2 times 3 2 times 2 is 4. 2 times 2 is 4. 5 times 3. Okay, I think the answer is 1,260. This is the LCM. That's according to this method. I don't know whether it's right or not. Even this method will be like
Yeah, that's correct. That's very correct. You want to take us through the other method? Yeah. Okay, now this one is okay. That you just look for numbers that divide exactly. When there are no more, then you stop with that, not so? Now, you reached here, not so? And they didn't divide. Don't you think that a student can simply use that instead of it's repetition, not so? That's when you reach the point of non-division, just multiply that way. See? Or else continue down. That me I was saving time because math is speed and accuracy. See? Now that is very good. This LCM is so big to be generated. I will give you for a smaller number that you can generate it by the other. Which method are you using?
Listing.
Listing. This one. Okay, come and use listing. You can because these numbers. HCF, you have two methods. Okay. First of all, I think this is clear. We don't need to maintain it. We remove this method. Yeah?
Okay. On the highest common factor, I can use listing method. First, then I'll use the factor tree. Factors of 36. Yeah, 1, 2, 3, 4, 6.
That means test well with your calculator. 36 by 8. Does it divide?
No.
So what's the next factor here?
You keep yeah, just keep on pressing the natural numbers.
9. I think central, right? Yeah. Then we got factors of 60. We have 1, 2, 3, 5, 6. 15, 4, after this. And then 10. 10. Yeah, after 10 it's 15. Okay, let's stop there.
No. After 10, it's 12.
Okay, 84. 1, 2, 3. Are you sure?
Yeah. 8 plus 12. Seven. 12. That is okay. So we look for the common factor.
If you're looking for the highest common factor, here we have very many common factors. We have, but then we look for the highest. And it's like in 36 we have 12, 60 there is 12, 84 there is also 12. So the highest common factor is 12.
I think, okay, we completed all those factors till we reach like 36, 60, and 84. Don't you think there are some other factors there that are common?
I think so. But seriously. Okay, let me use
But
my
why are you correct? You are correct, why?
Because the method analysis is right. It has given me a right answer.
But her question seems to say that you are not correct.
Okay, teacher, in case we are to complete all the factors,
Why do you think that is very important, and why do you think it did not affect her?
I think completing all the factors is important because it will help us get the highest.
Why didn't it affect her?
Let me ask you a question before that. Right now, the number we're using is very enormous. It's 84. So if we complete all the factors right now, it will take us a long time and later.
Another day.
Yes. Okay, so let me
But
explain.
why? I was trying to find out why is she correct despite her. No, you see, if you don't complete, sometimes you can fail. But first she is correct.
Teacher, according to where she has stopped here, the highest there is 12.
You
According
see.
to where she has stopped.
Because this set has more. Not so?
Yes.
That means you use the lowest value to make sure you end, because this can tell you.
Yeah.
Not so? But when you don't, it can be a risk.
Even 18, I think
Mm.
it's about
18 is there.
As
But
for now,
coincidentally, she correct by coincidence. Yeah, but it's wise to complete if you decide that method.
It's hard.
yeah.
I think the only thing is that you are not putting in the calculator, you are guessing some. Just get 36 over 2. 36, whenever divides you list. Not so?
Now let's use the third method. This one is called the factor tree. So we are looking for factors of 36, factors of 60, and factors of 82. So 36 divided by 2. It's 18. Then 18 divided by 2. But 9 can't divide. No, 9 can be divisible by 2, but it will leave the remainder. So we use 3. 9 divided by 3. 3. And 9 by 3 divided by 3. Factors of 6. 6 divided by 2. So 30 divided by 15. Sorry. 15 divided by 3. 5 divided by 5. So we go to 84. 84 divided by 2.
Excuse me. I think I'm going to mistake in this of the factor. 30 divided by
Thank you for that. Thank you for my correction. 84 divided by 42. 42 divided by 2. 21 divided by 2. Okay. 7 divided by 7. Okay, now here we look for the position where these numbers, how can I explain it? Like you see these numbers, 2 times 2 will give you 4, and here it will end with 3. If you look at this second last step, all of them are ending with 3. Right?
The greatest product, the greatest common
2
product.
times 2 times 3, which is 4.
Yeah, that's very marvelous. The greatest common product appearing in both is 2 times 2 times 3. All have that.
So let's go to the LCM. LCM,
Yeah.
use the listing.
Use 2 minutes.
We're looking for multiples of 36, multiples of 60, and multiples of 80.
You have pressed on
I'm
the
not going to
calculator.
list them because this number is too big. I can't list all these factors and this one as well. Maybe this one. But use the same. Use the multiple of 36. For 36. 36 plus 36. Look at 36 times 4. 36 times 3. 36 times 4. 100. I'm not going to list them all. Let's go to 60. 60 plus 60 will give you 120. 120 plus 60 will give you 180. Like that. So we go to 84. Like that. Till you get that.
Okay, guide us now.
I can't list all of them.
Having listed
You look for the common.
the
one
common,
that is here, here, and here.
the common smallest or common biggest.
Always.
That's okay, thank you. Now let me give you some, that's very, very good. We can't add to that. Let me give you word problems. That means the application of LCM and HCF in real life. That's word problems. Now you write this and you'll be telling me, is it, will it need the LCM or HCF? Write this question. 3 pieces of timber, of length 166 meters, 288 meters, and 360 meters are to be cut. And 360 meters are to be cut into smaller pieces of the same length. Into smaller pieces of the same length. Find the greatest possible length which can be cut without leaving any remainder. Find the greatest possible length which can be cut without leaving any remainder. What would that be with the clear explanation? GCF. Explanation for choosing GCF as the solution?
Greatest possible.
Greatest possible. And also cutting down, splitting of the item. Then you have this. That means you'll answer that, not so? 3 bells ring at intervals. 3 bells ring at intervals of 20, 32, and 42 seconds. 42 seconds. If they begin ringing together, after what length of time will they ring together again? After which length of time will they ring together again? What is that? LCM. Why? Why is it LCM? Joining, combining events. Because a multiple is a product of two things, not so? Yeah. Now, this one, find the sum of money. Find the smallest sum of money. Find the smallest sum of money which can be given to a family so that a child, mother and father can get 7,500 shillings, 7,500 shillings, 9,000 shillings, and 12,000 shillings respectively. What is that, and the reason? The reason is the smallest. Yeah, now you're here in the last question. The sitting room of a house measures 1,440 centimeters. 1,440 centimeters by 1,640 centimeters. Its floor is to be tiled using squares. Its floor is to be tiled using square tiles which are as large as possible. Then part A. Find the size of these square tiles. Find the size of these square tiles. Then part B. How many square tiles are required for this purpose? So, how are you moving on with that? Just comment on part A, the rest you. Which approach? Why? One reason from the question. You are splitting, but else another reason, that's one reason. That's very true. You'll try those. Let us go to prime factorization. Prime factorization here. just expressing a number as a product of its prime factors is what we call prime factorization. It is the expressing of a number as a product of its prime factors. Yes, as a product of its prime factors, hence find the square root. Yeah. How shall we express 36? Yes. Are you? Yes, guide us. We can. Then another one will guide us on 100. Use a factor tree. See how? Like she demonstrated by 18, then by you get by 3, you get 3 by you get, that means the 36 is 2 times 2 times 3 times 3. That's all. Or you can speak on this one will be 2 what? 2 square times 3 what? Or you can say how many? The first 2 times the second 2 and times the third, the first 3 and the second what? 3. So now we try to find the square what? Square root of now 2 squared times the 3 what? 3 squared. What do we do? Are you sure? Both have a 2. The square always dies with the square root. Is that very, very correct? That means each will lose its square to give us now 2 times what? Which is 6. Or a student could say, since both are sharing a square, since both have a square, not so. We could as well put it under one bracket, then we lose it at once. Okay? Okay, that's right. Now, out of 100? By 100. By 2. 50. By 2. 25. By 5. 5. By 5. 1. That means the 100 is 2. 2 times 2 times 5 times 5, giving us 2 squared times 5 squared, not so? That's a product. That will give you what? Square root of 100. That will end in 2 squared times 5 squared. Then this will cancel, giving you 2 times 10, which is 25.
No.
See. Yeah, that would mean that that's quite good, quite good. Would you test yourselves with the? You can test yourselves with that's a bit a cumbersome big number here. You are ready? with 576. Have you got the answer?
The square root.
The square root. Yeah, what is that square root?
Yeah, for me I've got 20.
24. 24. That's correct. How did you break that square root inside there? Your 576 was what?
2 times 2. Okay, it is 2 raised to the power of 6 times 3 raised to the power of 2.
That means you had how many tools? 6 of them. Then 3?
3, 2. I mean 2.
2, 3. Okay. Then you had to organize them in pair.
Yes.
Okay, that was great. 2 squared, 2 squared, 2 squared, and 3 squared. Then you removed. For a cube root, you organize them in cubes. 3, 3. Hope you know how to press that on the calculator for a square root and even a cube root. Could you test for me on your calculator? And I see whether you're correct. I want to show you get cube root on the calculator.
Cube root.
And you get for me cube root of a cube root of 512 on the calculator. Not by this method. And you see? Cube root. Okay, press square root and you see. Can't get square root of 81?
Can only get the square of 81.
Not square root.
Mine can get the square root.
Let me look at yours that can't get cube root and square. It can get square root and cube root. The button is here.
Okay, but cube root is not there.
Your button, sorry. Your button is has square root. Then this is a button. Then there is this part here of the button out.
Mine doesn't have.
Now, this calculator here, when you are getting square root, you press the square root button, then you put 81. You get? That button, do you see it? This button is here. Okay, your calculator would need you to first press 81, then the button. Yours is a bit ordinary, not like this. Now when you are pressing cube root again, you first see, you will have to, because this is a bit lower than this, you will have to press 512, then second, this button here called second, then you press that same button, it will give. But for that big one, you press, there is this button here having kind of X here, but not on the button exact.
Yes.
You first see, because cube root means a 3 here. What you do, you first press shift, then you press 3. You press shift 3. No, don't press 3 first. Press 3. Press 3 first, then shift, then this button here, and it will give you something like 3 with the, then you put your value here. You press now your value 512, which gives you 8. Do you get that?
Yeah.
Yeah. I wanted you to learn that. I think now you can evaluate this in your free time, won't you? This is your free time, not so? It can't handle?
Say you press 512.
Then press second function.
And the cube root. I'm getting 22.62. Then
You've now got it. Okay, that's great. Now we can shift to some operations on numbers, and we shall not go over very much. We shall only dwell on what we call divisibility tests. See, operations, because we shall not visit that order that 4 divided by 2. I think that one is on numbers, and particularly we are seeing what we call divisibility tests. See, yeah, any test you remember? When is the number divisible by 2? Yes, Chirabo. When is the number divisible by 2?
When it ends with an even number.
When it ends with even number or even 0. Yeah, that's point 1. That means 16 is divisible by 2. Why? 6 is divisible, is an even number. 3? Well, okay, let us start with 1. When is the number divisible by 1? All numbers are divisible by 1. Next, when is a number divisible by 3? Let us put, we put 18. Okay, why is 18 divisible by 3? Yes, Chirabo?
When a number is added, okay, when a number is added, okay, like for example 18, if you add 1 plus 8, you'll get 9, and 9 can be divided by 3.
That means the sum of numbers should be divisible by 3.
Yes.
Great. Next, when is a number divisible by 4? We are putting 44. Yes, permanency.
divisible by 4. If the last digit ends with
If the last digit ends with a multiple of 4.
not even multiple. It can't only be multiple of 2.
Hey, do you mean when the last digit ends with a multiple? Does 22 divide 4?
Yes. No.
No.
Then that rule might not be correct, not so? To be divisible by 1, all numbers. To be divisible by 2, the last digit is even number, or 0. To be divisible by 3, the sum of digits divide. What is the property to divide for?
The last digit is multiple.
Very, very sure? Let us test you here that the last digit is a multiple. 4 does 14 divide 4? That property can't hold me. The number formed by the last 2 digits must be divisible by. So this is divisible by 4. Therefore 128 divides 4. The number formed is 28. See, 44 is divisible by 4 because these 2 digits are divisible by. So 5, when do you divide 5? Yes?
When a number ends with either 2 or 3.
That's it. When do you divide the 6? Why is it 36 divisible by 6? Because see, a number is divisible by 6 if it can divide 2 and 3, both of them. See? That it must be able to divide both for it to divide 6. Does 14 divide 6?
No.
Because?
You can't divide 14 divided by 2 without dividing.
But it only divides 2. Yeah. We shall end on 10. You can go as past 10 in your research. 7. Why is 49 dividing 7? See, yeah. Let us find out. Does really 49 divide 7? Okay, why are these 2 numbers dividing 7? Test, do they divide on your calculator? Both divide. Now look, 9 times 2 is what?
18.
Minus 4 is? Does 14 divide 7? Yes, not so? 14 divides. The answer formed divides. Let's test. 14 divided by 7, it divides. 4 times 2, 8. 8 minus 1 is 7. See, look here. I think you'll discover what I'm doing. 2 times 2. 2 times 2? 4. 39 minus 4. 35. I think you're seeing, I use this to multiply, then subtract from the remaining numbers. See? That a number is divisible by 7 first condition, the last digit when multiplied by 2 and you subtract from the remaining digits, whether it is you subtract the bigger, that 9 times 2 is 18 minus the remaining number gives 14. 14 divides 7. When you look at this, 2 times the last digit times 2 is 4, subtract this one, it can divide 7. That you divide 7 on condition that when the last digit is multiplied, a number divides 7 if when the last digit is multiplied by 2 and the rest of the number subtracted with the product, the answer should be a multiple of 7 or 0. The answer should be a multiple of 7 or 0. That means when you multiply by 2, you get 18. Then subtracted 4, you'll get a multiple of 7.
Shall we get 28?
It will test 28 out of 7. We use this to multiply 8 times 2. Then we subtract.
Okay.
So we are now on 8. When does a number divide 8? Yes, Chirabo, you are trying.
The last 2 digits formed must be divisible by 1.
The last what?
2 digits.
Let's test. Let's test here. She's saying the last 2 digits must be able to divide 5, 6, 8. Divide 8. Does it divide? It divides, but you are saying for it to divide 8, then these 2 must divide 8. Is it true?
Yeah, it says the last 2 digits must be divisible by 2 and 4. That's what I said.
She's saying our rule seems to be true, but let us conclude like this. To divide 8 is the number formed by the last 3 digits. Divides 8. For 4, the number must be the last 2 digits formed. To divide 4, the last 2 digits. To divide 8, the last 3 digits should divide. So 9 gives like 3. I think you know now the answer.
You add the numbers, the sum of the numbers must be divisible.
To divide 10,
The number must,
The last digit must be divisible.
finished. Let us now go to place values and reading in words. Then that will shift us to integers. You can go to 11. See. You see, I'm going to request you to go and watch some YouTube videos on some simple multiplications. How do they multiply numbers? How do they add 7, 8? Because some of you will be, if we say add now, can you add using the head? See that? 12, 13, 11, 1, 1, 0. If we say add, you'd want to press a calculator. See? 0 plus 1 plus that plus that plus that plus that plus that is 6. You add vertically. What of here? This is 5 plus 13. Now you see I'm adding direct as I move. This is 13. This is 14. This is 17. 17, not so? I write 7. Yes, that is 5.
that is 12, 13, 14, 15.
And you get?
5 carry 1. You get 15.
You get 15.
Yes.
You write?
5.
You carry?
1.
This is 2, 3, 4, 5, 6, 7, 8, 9, 10. Not so?
Yes.
That's another way. You said here we get 17, not so?
Yeah.
That's funny. 4 plus 7.
12.
Huh?
11.
4 plus 7
11.
plus 1,
12.
13, 14.
Yes.
14. 1 plus this,
3. 6.
7, 8, 9. 9. Does it give the same answer?
Yes.
I didn't add while occurring.
Yes. Okay.
Yeah, go and watch some addition tricks. Yeah, how numbers can be added easily. How do we multiply this one easily? Multiply? You would say this. You would say 2 times that, you get 2. You get 4, not so? You get 1, you get 2. What if somebody just multiplied direct? 2 times that is 2. This times that is 2. Not so? Keep this answer is 2, 5, 2, not so? This times that. This times that plus this.
1
Huh?
plus 4.
That's tricky. See, we multiplied this, not so we got to multiply this, we got it 2. Then this times that is 1 plus this. That's a bit tricky. But make sure you gave me this answer as correct. Was it correct?
Yes.
Your calculator gives? Okay. Now I'm requesting you go and watch some multiplication tricks on YouTube. You'll enjoy how numbers can be multiplied ordinarily without this jungle of wasting a lot of time.
H one was wrong.
You'll add it well. But I'm requesting you go and watch how things are done without a calculator. Okay. Now let us shift to place values and reading in words, writing in words. Just remind me, let me use a very big number, you remind me their respective place values. I think I'll end in a million. Beyond a million, you'll go into millions, billions, and so on. Okay. What is this place value?
Ones.
Ones. Tens. Hundreds. Thousands. Then this.
10,000.
10,000. This is
1,000.
1,000. Then this one.
10,000.
10,000. Then next.
100,000. Then a million.
100,000. Then next is what?
A million.
1 million. Okay. Just practice out. I will not go into deeper details of this. Just to check whether people recall writing words. Beyond a million, what do you reach?
10 million, 100 million, billion.
Oh, then from a billion?
10 billion.
Then from a trillion?
10 trillion. 100.
Let us see. From a million, you go to?
A billion.
A billion. From a billion, you go to? Trillion. From a trillion, you go to? Quadrillion. From a quadrillion? Penta. Now, sexa. That's what? Can you help me? Pentrillion.
then sextillion.
You will generate more.
Sextillion.
See, octatrillion. Are there people who have that money?
Yeah.
Decatrillion.
Sure, for me, I'll get more.
Duodecatrillion.
I'll create my own.
This is really, you see, it's now writing words 2342301 How do you read that? 2210. Yes, can you read this?
2,301,211.
Oh, it's very simple now, I can see. What is this?
22. Is that one after?
This is 2, 0.
Okay. 22,012.
I will not waste time on placing, on reading in words. Let us shift very fast to integers or directed numbers. Next time when I come, you should have watched a YouTube video on some multiplication, addition, division without actually using a calculator. Yeah, I want the mathematical language skills. Yeah, that's very good. You also, I sent you to watch how an abacus can be used in multiplication of numbers. Multiply 23 times 44 using an abacus. Yeah, watch that. Abacuses are still being used in Japan, China, see, by merchants or traders. Watch use of abacus, then watch multiplication without a calculator on YouTube. You put in math tricks in YouTube. Look at puzzles. So integers, let us look at integers, directed numbers. See, have you ever thought of if you were standing on this table, on my teaching table here, on that table, and you jump in space 2 meters high, then instead of coming back to the table, assuming my table is the zero level, this is the table and this is the ground, you are standing here and you jump in air some 2 meters, and this is the 0 point. Then assuming you jump, instead of falling back here, you fall here, and this one is around the 4 meters. What distance do you think you'll have covered? You jumped 2 meters high but fell 4 meters below 0. 6. Would you have a negative distance?
Yes.
Total distance moved, she's saying is 6 meters. Total distance from 0 to where you stopped. Would it be -4 or +4?
Negative.
-4. That means below a reference point or below a certain level of decision. That's why when you go and borrow from a friend, in your pocket you have -200 shillings. Had you ever written down, if you borrow 1,000, did you write down in your box that I have negative 1,000? Of course, when you borrow, then the money is negative, you have negative. You don't say you don't have, in fact, don't even tell a friend, I don't have money, no. If you have debts, when they say, how much do you have in the pocket, say, I have negative 1,000. Because you have money, but in negatives, no? See, now, if you walked steps in front and you returned back, see, see, math is so interesting. Do you think so? Yeah, I also think so. See, and we are requesting that see, we make our subject very interesting. When we are eating food, calculate well. Don't finish don't finish a portion before the beans get what? Yeah. Now, that means we realize that we have both negative numbers and positive numbers. Remember, originally the numbers that were used were positives, then scientists began to think otherwise, that if a thermometer is reading 20 degrees right now, and tomorrow the temperature falls by 40, what will it be reading? If my thermometer is indicating 20, then tomorrow it falls by 40 units. It will be indicating negative. See? That means we have both negative and positive numbers. Therefore, integers are defined as what? Neutral. Now neutrality it must be tested. Now here we just have what we call a reference point, which is 0. That means integers are both negative and positive numbers, period. Do they end? Can you exhaust them? No. No, they are uncountable. So, okay, let us go to operation on integers. We are trying to see how to stop. And we are going to start with what? Addition and subtraction. We shall test our skills a little bit. Work out H using a number what?
Teacher.
Number, yes. Never. Integers, we have defined them as both is a set of negative and positive numbers, including 0. See? See? You don't believe that?
I believe that.
Oh, you don't want to believe? Please do believe.
Oh, really?
A set of both positive and negative numbers, including 0. Work out each using a number line. So, positive 2 plus negative 4. Now, negative value indicates opposite movement, not so?
Yes.
Yeah. How would we see that? Our number line, of course, is a continuous line. Must have 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. I'm first having positive steps, not so?
Yes.
Positive how many? 2 positives. You count from a reference point 0. That means up to 2. Not so. Then you are reversing how many?
4.
4 steps. Count, that means 2 is going now to become our starting point. Together? Okay, tubale kati, eno 0 not so, kati bala, 0, 1, 2, 3, 4. That means you will have, you have ended with this one plus that. What is the total movement from the total end? Negative 2, that's very flat, very flat. Could you test yourself for negative 2 or minus 3? Now, let us show somebody here. Those who are not well acquainted with these integers, look here. The easiest way to see is also this. You'd have how many positives? 2 positives. How many negatives? Now, each positive neutralizes a what? How many remain? 2. You see? Now this one can be attempted in this one has only negative steps. There is no positive. Or else you would see it from our observation here that you have negative 2 and negative 3. Therefore 2 negatives, nothing is cancelling the other. Therefore you will get what? Negative 5 without even having bothered yourself on the number line. Maybe to put for somebody on the number line. Okay, you are guiding me there, are you?
Yes.
So, Penny guide us here. What are you doing?
A plus math is going to be negative 2.
Negative from here to here, not so?
Yeah.
Then
we add.
we follow more negatives.
Yes.
Follow more. How many? 1, this is 0, where we end, we start from there. 1, 2, and 3. That would give you that, not so? That's negative 3. The final answer is?
Negative 5.
Now, me, I want to test you also with like 3. Then I'll know that you've understood. And I shift multiplication and divi. Yeah, and we will close. You seem to be you seem to understand this.
Yes.
Let me test it only. Now, basing on the same knowledge, I hope you recall, since you have told me that you are acquainted with that now, let me test you here. Handle for me negative 6 plus 8. What do you get? We get? All we are together with that? What of negative 10 plus 36 plus negative 20? Then 20 negative 10. Yes, Chiraba, here?
We get positive 6.
Positive? 6. What happens?
It's positive
16, positive. Then here?
20. It's positive negative.
Let me see, negative
Negative 10.
negative 10. Let me hear more answers.
Negative 30.
Then we discuss over why those answers are so. Negative 30.
I think it's positive 10.
Positive 10.
That's according to your body.
Now look here, I think here we agreed that few negatives are cancelling with the 6 positives, leaving 2 positives. Here, negatives are 20, they remove 20 positives, leaving
16.
Then here, if there are 2 signs, you multiply, not so?
Yes.
Negative times negative,
It's a positive.
therefore you end up with This gives us, giving you now what? Right, not so? Patience seems not to be comfortable with it.
What?
Oh, you are now comfortable. Let us find out. -5 plus -6. Hey. Let me shift it to multiplication and and we shall not take, because people seem to be covered that with vectors. Now, multiplication and what? You remind me those simple rules before we engage ourselves in there. Remind me, positive times a positive, you get positive. Negative times a positive, negative is powerful. Negative times a negative, positive. Okay. Then positive times negative, negative. Positive divided by positive, we get a positive. Negative divided by a positive, still negative. A positive divided by negative, still negative. Negative divided by negative, we get positive. Get positive. Work out. I want 2 times negative 2 times negative 3. How do you arrive at the answer? Is a positive. Therefore you get positive 6. -2, -20 divided by 4. We get -5. That's very good, because a negative divided by. Okay. Then I think -3 divided by -2, you get? Positive 1 whole number? 1 out of 2. Now, let us close with the concept of body mass. You recall body mass concept?
Yes.
Which signs do you first handle? Okay. That has been very, very good. Body mass in integers. Now there is also something called the body mass, but that one we shall see it when we have numbers with the powers. That for the case of today, body mass means what? Stands for?
Brackets of addition.
Brackets of division.
Multiplication, addition.
Okay, let me give you some trials here. You help me, and we pick you to come and answer, and we close down our lesson. Let me pick for you these trial numbers. You pick one, discuss it, and that will be the end. -3 plus -4 times 2. The -2 plus -3 times negative 1 plus 2. And you'd assist us with that. Just want you to come and discuss those things. Then do you seem to see the concept displayed here? I don't know whether you understand these pyramids. This is for addition. You add as you go up. This is for multiplication as you go up. Now let me have you, yes, Chirabo, come. Chirabo, take over this. Explain it very, very well. Out of her, will she explain this? Okay. Chirabo. You're explaining both? Yeah, both. Will you take over the pyramids? Yeah, go ahead, Chirabo.
Okay. According to both maths, the first thing that we shall work on is the brackets. So it will be negative 3 plus negative 4. So a positive times a negative, we get a negative. So it will be negative 3 minus 4 times 2 still. So it will give us negative 7 times 2 to give us negative 14. Patience. Have you understood? Okay. We shall also work on the brackets. So we shall have negative 1 plus 2. And then here addition, okay, there is no subtraction, so it will remain negative 2 plus negative 3. So a positive, any number without any sign is a positive. A positive times a positive remains a positive. So we shall have negative 1 plus 2, we shall get positive 1 times. Because if something is in a bracket, it means multiplication. So times what we get here, a negative times a positive times a negative, we shall get a negative. So it will be negative 2 minus 3. So it will give us positive 1 times negative 5. We shall get a negative times a negative, a positive times a negative will give us a negative. So our answer shall be negative 5.
Okay. She has tried. I will take on the pyramids. Okay, thank you, Chirabo. Now she has tried, but it seems here she disobeyed again the body mass rules. Yeah. Did she? Didn't she do so? That means she had to, as she spoke, she had to first handle this, not so?
Yes.
To get down what? Negative 1 plus 2, positive 1.
Yes.
Then she would now handle this and say this plus negative 3, now into positive 1. Then you hand these brackets first. Therefore, you'd have it as
Negative
2
plus
plus negative 3, which gives
which
That's negative 5.
I think our table, negative 2 and negative 3, negative, 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 anything cancelling, they are all negatives. Therefore, you get negative. Is that what she got? Coincidence?
I got negative 5.
That was so miraculous. See, let me guide you on the pyramid and you answer, not so?
Yeah.
Yeah, this is right. Now, a pyramid is just operate while going what? That this is an addition. That means add. This box is got by adding this. You fill here. Then this one you fill. This is an addition. Then here is got by adding. Add what is neighboring that. That means negative 5 plus negative 2 plus negative 5.
Negative
7 here. Then this and this,
We get negative 4.
negative 4. Then this plus that, fill here. For multiplication, you multiply, you don't add, and you move up, not so? That means this is negative 11. Then you handle multiplication. I want to give you one word problem, and we stop with the lesson. You are ready for the word problem? The temperature today is negative 18 degrees C. That means we are applying it in real life. The temperature today is negative 18 degrees C. If yesterday the temperature was twice as cold as today, twice as cold as today's temperature, what was the temperature yesterday? There you are. Lastly, this word problem is your last one. Simon has shillings 4,500. Simon has shillings 4,500 to buy lunch for his friends tomorrow. To buy lunch for his friends tomorrow. If he was given shillings 1,050 more, if he was given shillings 1,050 more by his employer, so how much money does Simon have? How much money does Simon have? So now your activity of integration, those ones you will practice them using the knowledge of integers. Yeah, your activity let me get your activity here. Your activity of integration integration. Now I think you'll just enjoy that. You'll just enjoy that exercise. You'll just enjoy that exercise. Yeah, you'll just enjoy that exercise, and we have ended there. Remember that we went through many things. We went through number systems and integers. Then we exhausted what's a number. We saw types of numbers. So we saw factors, multiples, lowest common multiple, greatest common factor, the applications in real life. And we also now went down to divisibility tests and ended in integers. This is the end of our lesson. We are going to meet in the next session. Thank you for attending.